There's a problem like this on the homework for section 6.9. They give you a function, and they want you to determine two things. What are the non-zero constant values of the nth order differences? Now that's a mouthful, but what that means is if we make our difference tree, what are the numbers that become constant? Okay, and then the second part is, what is the value of n? So what is the order of the differences? In other words, how many times do we have to calculate differences to get constant results? Okay? So I want to show you a couple things about this. I'm going to show you a good shortcut in a second, but I want to remind you of the process. So if I pull up the calculator, okay, if I pull up the calculator on this one, okay, now here's what we can do. If I want to build one of these difference trees, the calculator is really good at that. Okay, it's good at doing stuff like that because we can use the table feature. So, for example, if I want to do something like this, I want to find the y values that go with x equals 1, 2, 3, 4, 5, 6, and 7, let's say. I can find those really easily by just putting the function into the y editor in my calculator. So I'll put in negative x to the 4th plus 5x squared plus 13. Okay, hit enter. So it's in there now. Now if I go to table, and if I go to table and, well, I'll show you in a second. If I go to table, there we go. It gives me the y values back. Now, what if, like earlier today when I did this first period, my table started at like 500 or something weird like that. I don't want to manually have to go all the way up that list. So what you can do then is you can just go to table set, second F2, and you can set the starting value to be whatever you want it to be. So we would want it to be 1, which it is. So I would just put a 1 there, hit enter, and then I would go second table, and it would look like that. Okay, so here are the y values. It calculated all of them for me, right? So for x equals 1, I got 17. For 2, I got 17. For 3, I got negative 23. For 4, negative 163. For 5, I got negative 487. Negative 1103 and negative 2143. Okay? And now all I've got to do is just make my difference tree. Okay, so the first order difference is 17 minus 17 is 0. Negative 23 minus 17? No, 40. Negative 40, right? Because I'm subtracting. Adding negative 17 to negative 23. So negative 40, negative 324.
How is it a negative 17? I'm so confused.
Okay, what are you confused about?
Everything.
Okay, remember what the differences are. With the differences, we're just finding out how much is the y value changing. So to find that, we always subtract the starting value from the final value to see how much it changes. So 17 minus 17 is 0. Negative 23 minus 17 is negative 40.
But you said negative 17 before. So
Oh, did I?
Yeah, you said negative 17 plus negative 23 is how you got that.
Oh, yeah, it is. It is, because negative 23 minus 17 is the same as negative 23 plus negative 17. Right? Subtracting a number is the same as adding a negative. No, it'd be negative because, and think of this, that if I start at 17 and I end at negative 23, have I gone up or down? I've gone in the negative direction. I've lost, right? I've gone down by 40. Right? Negative 23 minus 17 is negative 40. Negative 163 minus negative, meaning plus 23, is negative 140. Right? Negative 487 minus negative, so plus 163. I hope I did that right. You might want to check it. negative 324. Negative 1103 minus 487 is negative 6. What? 23, 6, 20, 36? No. What is that? 6, 13, 6. What is it? 6, 16? Is that right? That doesn't seem right. Somebody got a calculator? Help me out here. Negative 1103 minus negative 4, plus 487. 6.
Negative 616.
Oh, okay, it is right. All right. And then negative 1040. Is that right? Okay. So those are obviously not constant. We got to go again. So we'll scoot down, do the same thing again. Negative 40 minus 0 is negative 40. Negative 140 minus negative 40, 100. Right? Because I'm adding, subtracting a negative. Negative 324 plus 140 minus negative is...
184.
Okay. And then here I'm going to get 282. No, 292?
292.
Yeah. And then negative 424. Okay. Oh, and these should be negative, shouldn't they?
Yeah.
Definitely not constant still. Negative 100 plus 40, negative 184, so that's going to be, right? Right? Okay, and then still not constant, but almost. Almost. We got it, finally. Okay? So then, what's the answer to our question? What are the non-zero constant values? Negative 24. Okay? What is n? How many times did I have to do this foolishness? I had to go, let's see, started there. There's 1, 2, 3, 4. So n is 4. Those are the fourth order differences. I had to calculate the differences 4 times to get there, right? So n is 4. Okay, now this honestly is not at all the way this is used. We would never, if we're given the function, we wouldn't really do this. There's no need to do this. When we would do this process was, if we didn't know what the original function was, but we had these data points, x equals 1, y equals 17, x equals 2, y equals 17, x equals 3, y equals negative 23, etc. If we had all that data, and we wanted to fit this to a polynomial, then that's when we could use these differences, right? We would have done the same process, but we would have found that because it took us 4 fourth-order differences before we hit a constant, what would the degree of the polynomial have to be? 4. Because the degree of the polynomial always matches the degree of the differences it produces, the constant differences it produces. So that would have told us that it's a 4th degree polynomial. Now, in our calculator, once we know the degree of the polynomial, all I have to do is regression. Right? So once I know it's 4th degree, I can go to my handy-dandy stat editor, right? So I can go stat edit, and I can put in the values, the x and y values. Now, how many do I need? Here's another thing that's we can take account of and save ourselves some effort. If it's a fourth degree polynomial, how many points determine a fourth degree polynomial? What's the rule? The easiest way, 5. Yeah, the easiest way to remember it is go back to a really easy one. What do we call a first degree polynomial? A first degree polynomial, what kind of a graph would that be? It's a line. Yeah, and we know that a line is determined, any 2 points determines a single line, right? There's only one possible line that can go through the 2 points, right? So that's an easy one to remember. If it's a first degree polynomial, a line, it takes 2 ordered pairs, 2 points. So that reminds you that it's always one more set of numbers, one more ordered pair than the degree of the polynomial. So if it's fourth degree, we need 5, right? So we could just look at the first 5 numbers, and that's all we need, right? Just these guys right here. And we could ignore all the rest. If I had data that went clear across the board, I wouldn't have to put any other stuff in. I'd just take the 5, right? And so we go back to the calculator, and that was 17, negative 23, negative 163, negative 487. Okay, got all the data in there, and now if I go stat, calculate, now look how this is organized. I don't think I've ever really pointed this out to you. If you look at the regression stuff down here, when we start doing regression, it starts at linear, that's first degree polynomial, right? Quadratic, second degree, cubic, third degree, quartic, fourth degree, right? So which one do we choose? Quartic. Yeah, so we go 7. Let's go ahead and while we're at it, let's store this as y1. We don't have to, but I'll go alpha F4, stored as y1. And then if I do calculate, well, that looks familiar, doesn't it? Negative, now look what this tells us. Here are the coefficients.
Please pardon the interruption. All varsity baseball players should dismiss at 2:15. JV does not dismiss early.
Okay, so look what this says. Now we got something of the form y equals ax to the 4th plus bx cubed plus cx squared plus dx plus e. Here are all my coefficients. So I get negative 1 x to the 4th. There's my negative x to the 4th. Now what in the world is this? This looks a little strange. What is this? Oh, I can't do it. What is this 2.9 e negative 11? It's an exponent. It's scientific notation, right? That's saying 2.9 times 10 to the negative 11. That's 0.000000000029. The calculator messed up a little bit. What's it really trying to say there? Once again, 0.00000000000029. Is that a big number or a small number? Small. Very small. In fact, that's pushing 0, isn't it? It's just trying to say 0. Sometimes the calculators will do this. When they give you some weird answer like this that says e negative 11 or e negative 14 or something, that's just 0. Ignore that, right? That's an extremely small decimal. So that's its way, just that we treat it as a 0. So I get negative x to the 4th plus 5x squared plus 13. Well, what do you know? That's our function, right? It had to be, right? I mean, that's all we did was test the calculator's ability to do regression. We already knew the answer, and it did it, right? But that's how we normally would proceed. We normally wouldn't have known the function. Now, if we do know the function, I'm going to show you a little trick. You're going to be kind of mad at me here, but that's all right. If you want to do these, because this isn't a very important problem. We don't do these very often. But this is a little calculus trick. This isn't in the book or anything, but I'll show you this trick. If we want to calculate what the non-zero differences are going to be, we take the leading term, negative x to the 4th, and we're just going to do this little trick on it until the x's go away. Here's the trick. We're going to take the exponent and multiply that by the coefficient and subtract 1 from the exponent. We'll just do that in steps. So the first step is going to be negative 4x cubed. So do you see what I mean by that? So we multiply the exponent by the coefficient and drop the exponent by 1. So let's go again. That's the first result we get. The second result would be what? X squared. Good. The third result would be Okay, and the last result would be what? Negative 24, x to the 0, but what's anything to the 0? 1. So it's just negative 24. Now that looks familiar, doesn't it? It's a lot easier, right? And then if we want to make the other correlation, well, you already knew the answer to this one. The other correlation is really simple. Whatever the degree of the polynomial is, automatically goes there, right? So when you do these on the homework, feel free to use that trick. You don't have to make the table. Okay, but you are going to have some of them where you have to. You're given the table, and you got to find the polynomial. Okay, does that make sense? All right.